Till now, you must have got an idea how nano world is. Now it's time to understand what is so special about nanotechnology. Nano is the world of molecules, atomic and subatomic particles. Nanoscience and technology is all about ultra small objects. It has a potential to reshape the world around us. It is going to bring enormous changes in our lives. This could lead to revolutionary breakthroughs in the field of science and technology. Hence, it is imperative to know the important facts about it, which I am presenting here. In a micro world, on reducing the size of the material, the properties remain the same. The chemical properties like its color, conductivity, hardness, etc. will depend on the material it is made up of and not depend on its size. Think of a copper rod. It has some specific properties like conductivity, ductility, hardness, etc. depending on the atomic makeup and electronic configuration of the copper atom. If we cut this rod into small and smaller pieces, the smaller pieces will have same properties as that of the original long rod. But at nanoscale, the case is not the same. If we keep on reducing the size of this copper rod up to the size of few nanometers, the properties exhibited are different than that of a bulk or micro scale copper. Bulk copper is a ductile metal with very high thermal and electrical conductivity, and the copper nanoparticles have morphology round and they appear as a brown to black powder. Nano copper particles of size less than 50 nanometers are super hard materials that does not exhibit the same malleability and ductility as the bulk copper. In the same way, when copper is reduced to nanometer dimensions like ultra thin films or nanowire networks, its optical properties change dramatically due to quantum and surface effects. It can become transparent, as shown here. Taking the case of nanogold. This art piece is made up of gold nanoparticles. The red, blue, green colors seen in this painting are nano gold particles of different sizes. As the color of the gold nanoparticle changes with the size, different colors are obtained by reducing the size of the nanoparticles. Gold and silver illustrates the unique properties that occur at the nanoscale. Nanosilver can appear red or blue depending on the size and shape of the particle. These particles interact differently with light compared to the large scale nano or silver particles due to the quantum effects. Hence, the size and shape matters at the nanoscale. The objects behave differently at nanoregime. The physical and chemical properties change with the size of the material particles. And this size and shape dependence of properties gives nanotechnology an amazing potential. The most exciting feature of nanoscale is that the nanomaterial have properties that are different from those of same material in bulk form. Most nanostructured materials are crystalline in nature and they possess unique properties. The properties of the nanomaterials vary with the size, shape and composition of the matter, and this makes nanotechnology very special. The reduced size of nanomaterials result into the size effects like increased surface area and modified electronic configuration due to the quantum confinement effect. Nanomaterials are more reactive due to their large surface area and they behave differently than the bulk material due to the increased reactivity. Also, at the nanoscale, due to quantum confinement effect, nanomaterial possesses higher energy electrons than the bulk materials, and materials band structure is modified. That influences the properties like electrical, optical as well as mechanical behavior of the material, resulting into the peculiar nature of nanomaterials. As at the nanoscale regime, material properties are size and shape dependent. A scientist can literally fine-tune a material properties of interest by changing the size and shape of the particle. Just imagine, you can design a material of your own choice. This concept of tunability in the properties of the nanomaterials is the fascinating and powerful result of the quantum confinement effect at the nanoscale. This provides us an opportunity to customize a material properties such as melting point, fluorescence, electrical conductivity, magnetic permeability, and chemical reactivity that all can change as a function of the size and shape of the material particles. Hence, nanotechnology is not simply working at ever smaller dimensions. Working at the nanoscale actually enables scientists to understand and utilize the unique physical, chemical, mechanical, and optical properties of materials that occur at this scale. When particles are created with dimensions of about 1 to 100 nanometers, the material's properties can change significantly from those at larger scale form. This is the size scale where quantum effect can rule the behavior and properties of the particles. Nano is very small, so material required is very less. So the nanotechnological production will require less energy, fewer raw material to manufacture. And the products of nanotechnology will be smaller, cheaper, lighter, and more functional. Nanotechnology provides us opportunity for obtaining engineered materials. It has the potential to increase the efficiency of energy consumption, help clean the environment, solve major health problems. It is able to massively increase manufacturing production at significantly reduced cost. Finally, we can conclude that nano is a small and special kind of small, and the special features of nanoscience and technology is leading to revolutionize the world we live in. If you are interested in exploring the nano world more, catch me on YouTube channel PHYSIFER and find many more such interesting videos. And these are the references for further reading. In future lectures, now we will go deeper into the field of nanotechnology. Till then, brush up the knowledge given up to you up to this lecture. Thank you for watching.